Hey everyone, just following up on the lesson we had yesterday on the dilations and the similar polygon stuff. I'm going to do a little bit of a review. This PowerPoint presentation, the video, is going to be relatively short. What I want you to be working on, though, is there's a PDF in Google Classroom I want you to kind of go, and if you can print that down, awesome. If not, I want you to be looking at that. What I'm going to do that, I'm counting that as a it's going to be like a take-home homework quiz. You can use any notes that you have to help you through that. It is 42 questions. It's a lot of stuff. The stuff is relatively easy, but like I said, you can use your notes. You can use the video from yesterday. You could use the examples that I'm going to put in the video for today just to kind of refresh your memory. But I want you to go through and kind of count that, do that as a quiz. I'm going to count it as a quiz grade. And use it as a way to review the similar polygons and the dilations, just so we kind of understand that and make sure that everybody has that. So like I say, I'm going to go through and do a couple of examples of what we talked about yesterday, refresh your memory on some of the stuff, and then if you want to pause the video as you're going through that and work on all that section of the quiz, that would be awesome if you want to do that too, just so you see it and have it there fresh. But you can come back and watch the video as you go through it. So, to refresh our stuff, the first part of the quiz is going to be the dilations of the coordinate grid. If you remember, is you take your coordinate point of your original pre-image, which is the original, and you just multiply it by whatever your scaling factor is. To get what the coordinates of the new point, so what your scaling factor is, you'll have. What the part of the quiz is going to do is I've given you two shapes. In like my example here, I've given you a red shape and a blue shape. I think online they're black and blue on your the PDF that you can see. I think they are colored on the PDF. What I want you to do is from the two pictures, I want you to tell me what the scaling factor was, whether it was an increase or a decrease, and then what the factor was. So my example here, I'm going from the red shape. So the red shape is my pre-image. When we kind of look at that, we'll just kind of write this in that the red is the pre-image. So that makes the blue the new one. So I got to figure out what scaling factor did I use to go from the red to the blue. So what you do is you kind of quickly look and see what are my coordinate points. So if I look, I'll start with this coordinate point here, right here on my sheet. And if I count over, I look, it's like 1, 2, 3, 4, 5, 6, 7, 8. So this is -8, 0. That's my first point. Go around the shape clockwise. My second point is going to be the top left point. If I look again, that's -4. And then I go up 1, 2, 3, 4, 5, 6. So that's -4, 6 is that point. Again, continuing clockwise, I come over, I have here my x is 6, my y is still 6, and the last point I come down, it's over -2, and then down -4. So I have what my original points were to look at what my scale factor is. So when I look inside to go to the blue shape, if I look at my points that's on the axis, I go from -8 to -4. So it's making me think that my scale factor is probably going to be -2, because this point in here is -4, 0. I just want to look at maybe one more to see. Maybe you should do all four to make sure. So if I look at my second point, I went from -4 to -2. So that's down by 2. I've also gone from 6 to 3. So again, this is -2, 3 is my new point. So each coordinate has gone down. The x and y value has gone down by 2. So it looks like my scale factor is basically 1/2 is what my scale factor is going to be. Or I reduced it by 2 if you want to say it that way. It's better to say 1/2 because if it's less than 1, it's obviously a reduction. Just double check my last point quickly. This point is 3, 3. Again, reduced by 1/2. And my last point here, I'm going to write it over here, is -1, -2. Again, reduced by 1/2. So there, I've gone from the pre-image, the red, to the blue shape, the prime image, and my scale factor is that negative 1/2. That's all you're doing is find what the points are, multiply or divide by what you need to get to the new points, and off you go. Hope that makes sense. So you can work on those problems on the home quiz. Next, what I'm going to do is you are given a pre-image. So my red shape, I'm going to change my color here so you can see it, show up a little bit better. What I've been asked to do is to reduce this shape by a scale factor of 1/3. Again, I don't have the coordinate points, so I have to go find what my coordinate points are. I am going to quickly call these points A, B, C, and D for simplicity. So if I look and quickly, my point A is -3, 9. Point B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 by 12. Point C is 6 up 3. And point D is -3, 3. Again, we're scaling it by a factor of 1/3, so I multiply all my coordinate points by 1/3. I'm basically dividing by 3 to make it easier. So my new A point, A prime, is going to be -1, 3. B prime will be 4, 4. C prime would be 2, 1. And then D prime would be -1, 1. So again, I have my new points. I just go in and plot those points and see what my new shape looks like. So my new point is -1, 3. So here is my new A prime. 4, 4. So I go over to 4 up 4. Here's my new B. That's B prime. C prime is to the right 2 up 1. Put the C prime out here. And D prime is -1, 1. So this is D prime. Whoops, sorry. This is D prime. I'll write this one over here. And then you just draw your shape in. So it looks like we kind of have a new shape that looks like this. Again, it looks similar. We have our factor. And now I have what my new shape looks like. Again, that's the type of problem you'll see on your home quiz as well. It's stuff we're going to expect you to be able to do in this unit, is to take a factor, or take a picture on a grid, scale it up or down, depending on the factor. So you have to find the points and know what you need to do. Okay. Similar polygons. This is the exact example from yesterday's class. I'm going to go over it again just so you remember what you're doing. Remember, similar polygons, all the corresponding angles have to be congruent. So you're going to be given angle measures or the congruency arcs in the corners. And then all the corresponding sides are proportional. So remember, you have to find the corresponding sides. Corresponding side is opposite the congruent and corresponding angles. So if I look quickly, I have X has 4 arcs in it, Q has 4 arcs in it, so that tells me X is congruent to Q. So my corresponding side for X and Q would be the 15 and the 10, the opposite side. So again, we're told they're all congruent. I see that they're all congruent, so we're good there. Now I just have to figure out, are all the sides proportional? So again, I'm going to use the W shape as the top number. The P shape is the bottom. So my sides are going to be 12 over 8. My other side is going to be 18 over 12. I have another side is going to be 15 over 10. And my fourth side is going to be 9 over 6. Quickly look through this. I can reduce all of these fractions. It's always easy to reduce the fractions because I look at it and I don't know what my scale factor is because all my numbers are different. So I kind of simplify everything down. I can factor both of these by 4, so I end up with 3 over 2. I can factor both of these by 6. I end up with, 3 over 2 again. I can factor these by 5, so I end up with 3 over 2 for a third time. Here I can factor by 3, I end up with 3 over 2. So now I look and see my scale factor. Whoops, sorry, that should be 3 over 2. Sorry about that. So now I see my scale factor in this example is 3 over 2 or 1.5. I'm not concerned whether it's 1.5 or 2/3, depending on which shape you put on top or bottom. I put the bigger shape on the top. So you could either have had 1.5 or 2/3 on this. Just make sure you have the scale factor. Remember as well, you're going to be given shapes. We're going to be solving for x. So in our example here, my corresponding sides are 12 over 18 is going to equal x plus 1 is my side for that triangle over 24. I know we worked on this one yesterday. We found that x was 15, so you just cross multiply everything. I would end up with 18 times x plus 1 equals 24 times 12, which worked out to be 18x plus 18 equal 288. I move 18 to both sides. From both sides, I get 18x equals 270, which when we divide that out, x equals 15. So those are the types of problems you're going to see on your quiz. Again, solving for x, finding if some shapes are similar, and remembering what you need to do setting up the proportions. So hope everybody understands that. And the last thing I want to review is all the stuff for the similar triangles. When you're looking at similar triangles, you can use the same rules that you have for similar polygons, because a triangle is just a three-sided polygon. All a polygon is a many-sided figure. So when you're looking at similar triangles, you can just stay with the simple, all the angles are congruent, all the sides are proportional, or you can use these other ones to kind of, you don't have as much information. We can go by angle. If any two angles of one triangle are congruent to two angles of the other triangle, then the triangles are similar because that makes all three angles congruent. The side similarity is if two angles are similar, if all the corresponding side lengths are proportional. So you just have to make sure you're matching up the corresponding sides, figure out what the proportion is for all three of the sides. If those three proportions are the same, then the triangles are similar. And the last one was the side angle side similarity, where that told me that if two side lengths in one triangle are proportional to the two corresponding measurements of the other triangle, and then that included angle is congruent, then my triangles were similar. So we have our example here. We're trying to figure out, are these triangles similar? I look, they've given me the measurements of two sides. I'm actually going to be able to use the side angle side similarity here because I have two sides with my included angles, which I look and see are vertical angles. So I know right away that those vertical angles are congruent. So now I just need to check the proportions, the proportionality. If you remember what I said yesterday, the corresponding sides on a diagram like this for triangles are the side lengths that share the transversal. So my 72 side is going to match up to the 40 side. And then the same thing, my 30 side is going to match up to 54. So my proportion is going to be 72 over 40 is equal to 54 over 30. So the quick and dirty way to do that, to figure out if your proportion is correct, is I can simplify everything down, and if they're the same number simplified, then that would work. The other thing is like we know to solve proportions, we can cross multiply. Well, to find out if these proportions are equal, you can still cross multiply, and if the numbers end up being the same, then you're going to have the same proportion. What I'm going to do is I'm going to reduce. So I can look at these and I can reduce both of these, let's say by 8. So if I reduce both of these by 8, my 40 becomes a 5, my 72 becomes a 9. So my factor there is 9 over 5. The other side works out to be 9 over 5. My triangles are similar. Common factor between 54 and 30 is 6. So if I do that, I divide by 6, I get 9 on the top. 30 divided by 6 is 5. So now I have 9 over 5 on both sides. My proportion is the same, and I end up with similar triangles because the two side lengths that I have are proportional. If you had wanted to do the multiplication of the cross multiplying thing, I would do 30 times 72 becomes 2,160. 54 times 40 becomes 2,160. So I can look at that and say, oh, yep, they're proportional as well because my two sides equal. So I know that I have similar triangles. Again, that's a quick refresher of what the rules are. Like I say, you have the PDF version of the at-home quiz to kind of see what you know what you're doing. I know it's short notice. I didn't really tell anybody what it was going to be, but this is what I wanted to do to make sure. Everybody seemed to understand this yesterday in class. In class, I don't know about at home. I didn't see any emails, so I'm hoping you understand it. Give it a go. Like I say, you're working at home. You have all the time you need to do it. I just want it to be uploaded to me. Let's say by 9 o'clock tonight. I'll put that in the classroom notes as well, so you know when to have it uploaded to me. Scans of all your work, so that I can see what you did and had everything correct. So everybody have a good day. If you have any questions, send me an email, and good luck on the quiz.